When we were studying linear functions, we had three different forms that we could write a linear function in. We had slope-intercept form, standard form, and point-slope form. Now that we're studying quadratic functions, again, there is more than one form that the function can be written in. We've already looked at vertex form. Vertex form looks like this, where the vertex is given within the function. And now we're looking at a second form, standard form. Standard form is written as f of x equals a times x squared plus bx plus c. Just like we could transform between various forms in our study of linear functions, we can transform from vertex form into standard form. And to do this, we need to remember how to multiply polynomials. The first step is to remember that x plus 2 squared is not x squared plus 4. It's not just distributing that exponent. I'm going to erase that because it's horrible. Instead, we need to first write x plus 2 squared as x plus 2 times x plus 2. And then after we do that multiplication, we will subtract 3. So multiplying x plus 2 times x plus 2, we could use the box or we can use the distributive property. I'm going to go ahead and just distribute. X times x and then x times 2 gives me x squared. So x times x squared. X times 2 gives me 2x. And then 2 times x plus 2 times 2. So 2 times x is 2x. And then 2 times 2 is 4. So x plus 2 squared, that portion becomes x squared plus 2x plus 2x plus 4. And then we need to subtract 3. Combining like terms, we end up with x squared plus 2x, which is 4x, plus 4 minus 3, which is 1. I've done that multiplication and then subtraction of the right-hand side. That tells me the standard form of k of x is x squared plus 4x plus 1. These two ways of writing the quadratic function describe exactly the same function. This is the graph of that function, and this is the table of that function. Again, these are exactly the same function, just written in two different forms, vertex form and standard form. We can see very clearly that this is the graph of k of x equal to x plus 2 squared minus 3, because we know the transformation rule, left 2, down 3, left 2, down 3. We also know that the vertex is x equals negative 2, y equals negative 3. Negative 2, negative 3. And then this is the table that goes with this graph. We can find the y-intercept of this graph just by looking at it. Let's go ahead and look at it. The y-intercept of this graph is 0, 1. So the y-intercept of k of x is x equal to 0, y equal to 1. That is the y-intercept whether it's written in this form or in this form. I'd like you to see that we could have directly found that y-intercept by plugging in 0 into our function rule. So we plug in 0, 0 squared, 4 times 0 plus 1. What happens is my x squared and my 4x term become 0, and k of 0 is just 1. K of 0 gives me the y-intercept because the y-intercept is the point on the graph when x is 0. I'd like you to notice the big idea here, which is that this 1 comes right here from my standard form of my function rule. So I was able to directly identify my y-intercept from standard form by looking at c. So when I plug in 0 for x, which is how I find my y-intercept, these first two terms of my standard form disappear, and all I'm left with is c. That means when I'm given a standard form equation, I can directly identify the y-intercept just from the function rule. The y-intercept is that constant term at the end of standard form.